Hello, welcome to this lesson on our study of functions. Alright, so if you have not subscribed to my channel yet, kindly subscribe for more videos. Okay, let's start. So in our previous lesson, we discussed about what a function is, the definition of a function, and some things we can do with functions, evaluations of functions, roots of functions, domain and range of functions. Okay. Now in this video, we'll discuss some special types of functions, what we mean by a one-to-one function, what we mean by an onto function, and even an odd functions. Okay. Alright, so let's start. Now to start with, you say that one-to-one function, the function is said to be one-to-one if different elements in x, okay, this x that we pick, have different and distinct images in y. Okay. Now what this means is that for every value of x that we pick, we'll get a distinct element of y which is different from the remaining y's. Okay, so in mathematics, this is how we write it. Write it like f of a should be equal to f of b, and this implies that we should always get something like a equals b for a one-to-one function. So we have these two tasks here to go through if this and this are both one-to-one functions or not. Okay. Alright, so let's start. Now to start with, we are saying that for it to be one-to-one function, f of a should be equal to f of b, and at the end we should get a equals b. Okay, so for the first one, f of a is actually equal, just putting a in place of x, so we get 1 over a plus 3. This should be equal to 1 over b plus 3. Okay, now if you do cross multiply, we get b plus 3 is equal to a plus 3. Okay, so I can subtract 3 from both sides, or simply saying that we'll group like terms. Okay, so if I write b minus a equals 3 minus 3. Okay, now that will let you see it clearly. We get b minus a is equal to 0, so I have b is equal to a, and in effect I can interchange them and say a is equal to b. I hope this is correct. B is equal to a is the same as a is equal to b, so far as we are dealing with equations. Okay, there is no logic in set. Alright, so with this we've been able to show that indeed this function is one-to-one. Okay, since a is equal to b. Now let's look at the second one. We're saying that f of a should be equal to f of b. Okay, now with that we have 1 over a squared plus 3 should be equal to 1 over b squared plus 3. Now if you continue, we'll get something like b squared plus 3 should be equal to a squared plus 3. Now with this, we'll get something like b squared minus a squared is equal to 3 minus 3. And get something like b squared minus a squared should be equal to 0, right? So I have b squared is equal to a squared, or the other way we can get minus a squared equals minus b squared, and in effect we'll get a squared equals b squared. Okay, now a is equal to square root of b squared. Okay, and now with that, let's move the screen to the top for you. Okay, now with this one, we can say that a is equal to plus or minus b. See, remember that always the square root will result something like this. Okay, now with this we have a equals plus or minus b, which violates this rule that a should be equal to b. This is the only way we can say that the function is what, a one-to-one function. Okay, we should always get a is equal to b. So this does not give us any conclusion on our one-to-one function. So it means that this function here, this function that we have here, okay, let me use the white pen, this function here is not a one-to-one function based on this mathematical rule. Okay, all right, so let's continue to other types of functions. So we have what we call an onto function. So an onto function is very simple for you to understand. Okay, we are saying the function is said to be onto if and only if the range of the function is equal to the codomain of the function. So the range, if you remember in our previous lesson, we discussed about range. Okay, so if I have, let's say, 1 2 3, okay, now I have, let's say, x y z, okay, and I'm seeing that one is mapping onto this. Let me write it. One is mapping onto this, two is mapping onto this. This is actually, in effect, this is somehow one-to-one function, okay, but what this is actually telling us is that for our codomain, the codomain here is what y is equal to what x. Sorry, let me use a different variable for the codomain. Okay, it's not necessary that every time y we should use y or something like that. Let's say f of x is our codomain and it's equal to x y z. Okay, this is what we have. Now what is our range? Our range is the image of, so let's say r of x, the range is the image of x in y or in the codomain. Okay, f of x here, this is my x. So the range is what? The range is the image of x. And what are the range? The range is x y z. Now you are saying that if these two are the same, then you have an onto function. Very, very simple, right? So if here was, let's say, some t is here, it means the codomain for this is actually giving us x y z then t, and the range is this, which will make it not to be an onto function. I hope you get it. So know the difference. Okay, know the difference. All right, let me erase my t here. Okay, so this is what we mean by an onto function. Let's move on to the next one. Now you call something an even function. You're saying that a function is said to be even if this condition here is satisfied. Okay, f of x equals f of negative x. Now let's look at, let's solve this. Okay, with this one, let's try to simplify it and see if it is true. Okay, these are examples, but with the second one we'll prove it later. Okay, we'll prove it in a different lesson. Okay, now if I have my f of x is that, let me find f of negative x and see if I'll get the same thing. We are saying that it's even if f of x is the same as f of negative x. So let me find my f of negative x. It means wherever I see s, I put negative x there, right? Plus 3. Okay, so this is the same as negative 1 squared from indices, then s squared plus 3, and this will give me 1 square. Negative 1 square is 1. Okay, so I get s squared plus 3, which is my f of negative x, and this is the same as the f of x we had, right? I hope this is correct. So this function here is indeed an even function, and we are saying that cos x is an even function. I'll prove this later, so kindly wait for the video. What we need to prove this, we've not learned it yet, Taylor series. Okay, so we'll do Taylor series in our subsequent videos or lessons, and I'll use that to prove why cos x is even. Okay, sorry. Now let's go to the last type of function, then we'll be done for the day. Okay, so we have what we call an odd function. Okay, so what is an odd function? An odd function, we are saying that a function is said to be odd if f of x here is actually called negative of f of negative x, right? I hope you get it. Let me try to show you with this example and you will understand. Now we are saying that if f of x here is equal to negative of f of negative x, then we have an odd function. Now let's look at this. For the first one here, we have f of x is equal to s cubed. Let's find f of negative x and negate it if we get f of x back. Okay, now f of negative x here is equal to negative x. Wherever we see s, we put negative s there, then cube, and this is equal to negative 1 cube then x cube. Okay, so we have negative s cube. Okay, that is what we have as f of negative x. Okay, So this is f of negative x. We are saying that f of negative x is equal to that. Okay, f of negative x is given as this. Now we are saying that if it is odd, f of x should be equal to negative of f of negative x. Now let's find negative of f of negative x. Okay, and that is equal to what? Negative of negative s cubed. This is equal to what? S cubed. And indeed, this is the same as f of x, because f of x is given as what? S cubed, which is this one. Okay, f of x is given as this one, and so f of negative x is also given as this one. But when you negate f of negative x, we get f of x back, which means that our function f of x equals s cubed here is an odd function. Thank you, and don't forget to subscribe to my channel. If you have not subscribed, kindly subscribe for more videos. Okay, all right.